very warm welcome to all of you. On behalf of SPIT IT Infrastructure and Services, I take this opportunity to welcome you all to one of our DevOps program initiative, under which we are planning to conduct courses on Linux system administration, server administration, network administration, security administration, as well as cloud computing, network management, and so on and so forth. So this is the very first program under a DevOps initiative, which is on AWS cloud training. And I would like to extend my warm welcome once again to all of you and my student volunteers and the trainer of today's program, Pawan Goli, Rohan Pawar, and Jay Salunke. So objective of this today's AWS Cloud Training Program is to provide you hands-on training on Amazon Web Services Cloud and try to impart the knowledge and skill set required in cloud computing domain. In order to have a hands-on laboratory session, I hope everybody has either you have already AWS account or you just have created AWS free tier account. So you can make use of this account for this today's training program. It is mandatory, as I said, for ETL course students to join this session. So agenda of this today's program is already shared with you. So we'll start with the AWS cloud services, and then account, how to set up account. We'll just run through the account setup. So Rohan Pawar will help you in how to make the AWS account. Already you are aware of it, just will run through. Followed by AWS IAM role. Then we'll start with the AWS EC2 instance. Jay Salunke will cover that part, and then how to start Ubuntu or Windows virtual machine under AWS cloud. Then how to configure, let's say, server configuration on AWS and testing it, and then we'll have a understanding of security groups. Okay, followed by AWS VPC, which is virtual private cloud, and then we'll have a AWS DevOps by Pawan Goli. So today with me, Pawan, Rohan, and the Jay are available for this today's session. So I will hand over the session to Rohan. All right.
Yes, sir.
Yeah.
Yes.
Just run through AWS account creation. All right, that's the very first step. Already you must be aware of it. Just quickly take this session. Over to you, Rohan.
Yes, sir. Thank you so much. So Rohan here. I hope I am loud and clear, right? Can someone just give me a thumbs up and let me know? Yep. Thank you so much, sir. And now I'll be sharing my screen. Okay, so is my screen visible to you, all of you? Yeah. So let's begin. So how do you create your AWS free tier account? So you just need to type in, I'll increase the font size of my screen. Okay. AWS. So you'll find the first link. So over there, you need to click on create a free account. And it will take you to a sign up form. You need to fill in all these details. And currently I'm just logged in already. So that's why it just redirected me to the console, right? So I hope that is enough for you to get started with the AWS free tier account. And as Sir said, all of you must have already created the AWS accounts. So should I move on to the IAM, sir?
Yes, yes, you can.
Okay. Okay. So let me give you a brief idea about what exactly is IAM. It stands for identify and access management. So what to expect from the session? We will look at what is IAM concepts, okay, common use cases, demos, right, to help you get started, cover the building blocks. So what exactly IAM in AWS? It is a way to enable users or you to control who can do what in your AWS account. So let's say one organization has one AWS account and it is used by many of the users, like developer team, IT team, security engineers, DevSecOps, etc. So there are broadly three components of the IAM. One is user, group, and roles. User as in a single entity user, and groups is like you assign certain permissions to the group, and you when you create the user, you assign the users to the specific groups. So the permissions of that groups will be assigned to that user. And there is something called as IAM policy, and there is something called as policy document, which is nothing but a JSON uh, which encompasses all of the permissions and resources, and the you can also use wildcard in this. For example, asterisk defines all the resources in the given scope. Let us move on to the yeah. So this is control and security. So centralized IAM dashboard gives you that ability to control the privileges of all of the users in your organization from a centralized panel. And from the security perspective, we have by default deny, which means when you create a new IAM user, it will be by default deny. Okay, and you can also create multiple users for individual security and credentials and permissions. Right. So there is so to interact with your AWS account, you have two things. One is access key and security key. So security key is a secret key. So it is called secret key, right? With these two with these two keys, you'll be able to access everything in your AWS account. So IAM user can have both of these, and you can limit that user to have them, right? And it's all there is a root email root user, sorry, root user, yeah. So root user has the all of the access in your AWS account, so ranging from all of the resources like S3 buckets, EC2 instances, Lambda, etc. Everything. So so I would give you a pro tip that you should never give your root email address or root user privileges to any of the user. Like you need to protect your root user, so because it has all of the access to your AWS account, right? So when you create one IAM user, make sure you only give the only least privileges, how much the permission or privileges are required to that particular user. Okay, so access key and secret key are also used for programmatically accessing your AWS account. Like in this screen, I'll show you how to actually use your AWS. Sorry, yeah, and using AWS CLI, using AWS configure command, you can paste in your AWS secret key and access key, and by this you'll be able to access the resources. So let's say I want to access the S3. So I have a S3 bucket created called important docs SPID. So I'll just print the information about it. So currently it has a single file, myfile.txt. So it is called objects and total size of 12, right? So this is how you'll be able to access your AWS account with the help of AWS CLI with these two things called as secret key and access key, right? So let us move on to the next slide. So yeah, IAM users benefits and do and don'ts. Yeah, distribute your AWS root credentials. As I mentioned in the previous slides, you should never distribute your AWS root credentials. Use your root account user and share your IAM user credentials, right? Okay, as I said, there is no permission by default. You need to explicitly assign the permission to the particular user, to the particular IAM user, so that he or she can access the resources in your AWS account on your behalf, or on your AWS account, right? So yeah, this is some syntax of the policy. As I mentioned, this is a JSON policy document which specify who, what action, get put or something called as effect, which is allow and deny, and which AWS resource, let's say bucket, and as you can see, there is a asterisk over here, which is a wildcard. So it allows all of the access to the buckets in your AWS account, and this specify when until December 31 and 2017. Let's say this is a expiry or validity of the IAM users policy, and where from which IP range he or she can access your resources and how. Right? If using MFA, then allow. If not using MFA, then deny. So something like that. I hope you get an idea. So yeah, this is how the JSON of the policy document looks like, right? As I mentioned, there is something called as effect. So effect specifies the permission that allow or deny, right? Or and the action specifies the which functions that the particular user is allowed to perform. S3 get, let's say S3 get is a function which lets you access the S3 bucket contents and the resources. Yeah, this is asterisk over here, means all of the resources are allowed for this particular AIM user for which the policy is written. Okay, so okay, IAM policies. Two types of. Just a second, I'll just. Yeah. Inline policies are there. Two types of identity-based policies. So yeah, I won't bore you with the theory part. So let's get our hands dirty and create an actual IAM user, and let's see how it goes, right? So this is my AWS management console, right? All of you can see, right? So you just need to search for IAM, manage access to your AWS resources. So yeah, in AWS you have like information symbol where you can just click or hover over to see what exactly that component does. So as I search for IAM, it just show me the single line definition for what this component or what this service does: manage access to AWS resource. Okay, so yeah. So recently I've created an access key, so that's why it's showing me one warning. So deactivate or delete the access key for the root user, because it is not a good practice to have a access key and secret key for the root user, because it has all of the access to your AWS account. So currently we have 2 users, 2 roles, 0 policy, 0 identity providers. So let us create one new user. Okay. So on the left hand side, you can see user group, users, roles, and policies. Okay. These all of the components has been explained to you in the slides. Let's create one user. Okay. So I would like to call him Alex. Okay. So Alex will be given to, let's say he or she wants to access the EC2 instances. Okay. So let's say he's a developer. Okay. So I would like to provide him access to the AWS management console. Okay. Now, are you providing the console to access the person? Yes. And yes, I want to create an IAM user. So if you want to auto generate the password, you can just keep the settings on the default, or else I'll click on the custom password and I'll specify my password, which is this one. This is just random password. Now, yeah. Then we'll be clicking on next. Okay, so I would like to also, user must create a new password at next sign in recommended. So this is when the newly created IAM user, when he'll log in, so he or she will be prompted to change his passwords, because you want to keep track of what password was given to your IAM user. So you can deselect it like this, and the custom password which you are specifying over here will be stayed same. Okay, so this is the section where you can set the privileges or set permissions to that particular user. So let's say I want to attach policy directly. So you can also create your custom permissions, like you will need to create a custom policy document. But here AWS has given us the very variety of templates of the policy documents, as I've showed you in the slides, how you can define the policies and access and limit the users to access the resources and perform the actions. Okay, so let's say we want him to access only the EC2 instances. So there is a template for that. It is Amazon EC2 full access. Okay, when you'll click on this, let's say let's expand this and inspect what the permission does. Okay, so version, this is the version statement action. Okay, as you can see, EC2 colon asterisk. This defines all of the EC2 instances in your AWS account, and effect specifies is the actions or whatever the permission is allowed or denied, right? By default, it will be denied, but when you'll explicitly mention effect allow, then the permission will be given. Okay, and resource asterisk means all of the resources are accessible in the EC2 instances. So there are also some few other actions like CloudWatch, auto scaling, create service, LinkedIn. These are some deep concepts. So let us not go into that. You can also copy this JSON and create your own custom, modify the JSON and create your own custom policy document and create IAM user. So I'm good with this. So let's click on next. Okay. So just a second, I think I have not selected. Yeah. Okay. EC2 full access. So you need to click on this checkbox. Okay, as you can see, permission summary. There is a EC2 instance full access permission policy. Okay, so you can also add add few tags to this particular user, so that you want to keep track of which IAM user is what. Like I want to call in developer from SPIT. Sorry, SPIT. Yeah. So yeah, this is how your user is created. Okay. Yeah. Now, you can also email these credentials to his or her email address, but still we have access to this. So this is console sign-in URL through which your IAM user will be able to log into your AWS account when you click on copy. So as the root user session is going on in this browser, I will open a new incognito tab. Okay, I will paste in the URL for logging in the user, newly created IAM user. Okay, so as you can see, you'll be prompted with this login screen which says IAM user sign in. Okay, by default, account ID will be pasted in the account ID section. Let's say IAM username was Alex and the password was specified as this one, right? Let's say sign in. As you can see, as we have explicitly assigned the permission to the user to access the console, so that's why the console is being loaded. But all of the extra information or unassigned privileges, the cost and usage, billing, AWS health, everything is not accessible to this user because currently we are Alex, right? As you can see, I am user Alex. So that's why you can't access anything else. Let's say if the Alex tried to access S3, which has not been explicitly assigned to him. So let's see what error comes in. See, you cannot list the documents, list the buckets. Sorry, the Alex is unable to list the buckets. Even if he tries to create bucket, let's say SPIT registration bucket. Okay, and let's keep everything by default. And when I click on create bucket, it will show me an error called to create bucket. S3 create bucket permission is required, right? Because this has not been explicitly assigned to this user. That's why this is showing error. Okay, as you can also debug things if your infrastructure go very beyond the scope and it's unmanageable. For debugging purpose, they also return the API responses. Okay, so yeah, as we can see, we are unable to create S3 buckets, but the EC2 instance, EC2 full access has been given to this user. Let's see about the EC2 instance, right? Virtual servers in the cloud. Okay, let's try creating one instance. Yeah, so it says my DB server. Let's select one, Ubuntu. And yeah, you really want to make sure you are only touching the free tier eligible resources, not the ones which are paid if you don't want to pay. Okay, so this is free tier eligible. Now I'll keep everything by default. Okay, Jay will explain you everything about EC2 instances, about the key value pairs and network settings and security groups, and all of the stuffs about EC2. Let's just launch instance. Okay, so it says, uh, okay, I think I need to specify the key value pairs. Okay, let's create one. Let's call it Rohan. Okay, so the key has been created. As you can see, I have selected my key and I'll click on launch instance. Yeah, it's done. AWS is pretty fast. As you can see, the EC2 instance has been created. If I'll click on view all instance, I'm able to see my instance running, right? And also the EC2 full access has been given to Alex, so that's why he or she will be able to, stop the instance, reboot the instance, everything. When I'll click on select this instance running, I'll be able to stop or reboot the instance. Previously, it was grayed out because I have not selected the instance I'm targeting. Okay, let's try. So should I show the connection also? The newly created EC2
I
instance.
think Jay will cover this, right? Jay?
Okay. So I think I am has been understood by all of you.
Hopefully,
I'll
everything
share.
is done. Yeah.
Yeah,
Okay.
I'll share the document and let you guys play around with the IAM dashboard. So yeah, that's all, sir.
Yeah, please do share that account. Thank you, Rohan.
Yes, sir. Yes, sir. Thank you so much.
Yeah. So I will hand over the session to Jay. Yeah, please go ahead with the EC2
Hello
instance.
everyone, my name is Jay Sarunke. Is my voice audible to you guys? Is my voice
Yes.
audible? Okay. So let me just share the screen now. Entire screen. Letting display share. Okay. Is my screen visible to you?
Yes, I
Screen
can.
visible? Okay.
Yes, yes.
So right now we are just going to look how to what is the Amazon EC2 instance. So Amazon have created the Elastic Compute Cloud, that is Amazon EC2 instance, which provides an on-demand scalable computing capacity in the Amazon Web Service. So basically, Amazon EC2 is basically we are trying to create an VM inside the Amazon infrastructure, and it has lots of images. So rather than going to the theoretical part, I would like to show the uh, direct the tutorial to you guys. So this is the EC2 instance dashboard. So let's just click on the dashboard section, and in the instance you just have to click on the instance, guys, and click on the launch instances. So in this section we have to give the name to the instance that we are going to create. Let's suppose I want to create Ubuntu, right? So I will give the name as Ubuntu VM to it, and here at application OS images we have to select the images that we want to create. So here, guys, there are lots of image templates, as we can see. So here is the Amazon Linux, Mac OS, Ubuntu, Windows, Red Hat, SUSE Linux, Debian. lots of. So for now, we will create an Ubuntu instance. Just select the free tier eligible for that, and we have to create one key pair login for this. So this is a key pair. We have to create it because in order to, if you want to log in the SSH in the term, so if you want to log in into the local instance, into the local terminal, we have to create the key pair for that. So we are creating the key pair for that, and we have to give the name as Ubuntu VM one, and just create one key pair. In network settings, we are selecting by default VPC. In subnet, we don't have such preference and all. For security purpose, right now we are allowing the SSH traffic that to be allowed from anywhere, so anyone can access the our instance through SSH terminal. So through SSH, we can able to access the VM terminal. So for instance, we are going to allow this, and this is the storage related part. By default, the VM that we are creating, it is allocating one storage, and that storage is base storage, that is elastic block storage. Okay, so this is the configure storage part, and this is the general purpose SSD. What type of SSD you want? You want GP3 or GP2, and we want storage of 8 GB, and yeah, that's it. And we just have to launch the instance. So now we have created the Ubuntu VM. So to access the Ubuntu VM, there are two ways to connect it. So the first one is to through the Cloud Shell, and the second one is to the local terminal that we have. So first of all, we will look into how to connect to Cloud Shell. So just click on the Ubuntu VM and go into the connect section. In this, there are three types of there are three ways to connect to the instance. That is EC2 instance connect, SSH client, and session manager. So for instance, in order to connect the cloud, connect the VM to the cloud shell, we should select the EC2 instance connect and just click on the connect. So yeah, so we are now we are inside the VM, and we are able to access the VM that we have just created. We just clear the screen and see the what is the IP that we have assigned for us. So right now we have assigned with the IP 172.31.14 and 78. So this is the IP. So the second way that we can try to access these Ubuntu VM is through the local machine. So open the local terminal. Since I am using the Ubuntu, I am able to do this. Uh, okay, so let me. Okay, so to connect through the local terminal, we just go back to the instances, click on the connect section, and click on SSH client, and we just have to run this command. For Ubuntu, for the Linux machine, we have to change the permissions regarding the PEM file. If you are using Windows, you have to do the another settings. We will come into this. So right now, to access the VM through the local machine, we have to run the following command. So this, so just click on this, and let me just uh, let me move my PEM file to the current directory. So move the Ubuntu PEM key dot PEM file this. And so, so yeah. So just paste the command chmod to, so this will change the permission regarding the PEM file. Okay, control A, sudo. Hmm, link your job. Let me download that key once again. So I'm copying this PEM file into the current directory, the home directory, and just changing the file permission so that we can able to access it. Okay, and just uh, click on this command, and we are going to try to do the SSH. Enter the yes, and yes, we are able to log in now. The instances that we have just created, and if you see here, the IP for this is same as we look into the cloud shell. Yes, hello sir, hello.
Yes, yes, yes. So you can even try for Windows and connect to remote desktop. Will you please?
Actually, I don't have Windows.
Not an issue. No problem. So just now you proceed with the installation of web server and demonstrate.
Okay, sir. Okay. So now what we have to do is we have to download the Apache server for that. In the current instance that we have logged in, is this sudo. So just type the command sudo apt get update. So it will update the current database. And do sudo apt get install -y apache 2. This will download all the packages related to the Apache 2. So since Apache 2 service is not enabled by default, we just have to enable that service. So before that, let's just see the status of the Apache 2 server. Sorry. So it is Apache 2. Okay, so it's currently running. So if we do the curl command and try to access, so yeah, so if we try to access the curl command and current curl, uh, okay, sorry guys, if we try to do the curl command, so curl command is basically used to get the web pages we are trying to curl basically used to request the pages. So currently the Apache web server is running on port 80, and we are able to access the page that the Apache web server is presenting. So let's just now try to access this page to the web browser. Okay, in this page the IP address here. As you can see guys here that we are not able to access the Apache Web 2 server. So here comes the section called as a security group. So for the EC2 instance, we have not given the privileges to that the that to access the if anyone if anyone requests for the port 80, so it should show the Apache web server, and we have not given the permission the security groups in the security group. That's why we are not able to see the web page in the through the public IP address, but we are able to see this through the local host, that is the internal private network. So to access the Apache web server to the public address, we should go into the EC2 instance details, and in EC2 instance click on security, no sorry, networking, and in networking, no, let me check where it has in security groups. So at the left side there is a network and security group tab. In that, click on the security group. So we have so for the current uh, instance we have launched, let's just see what is the security group that is assigned to it, which is launch wizard 8. So click on this, and 890 CPU. No, this is another one. So as we can see that in the security group, we are now only able to access the so the user can able to access the uh, terminal to SSH only. We have not given the access to access the Apache Web 2 server to the public IP address. So to give the access, we have to edit the inbound rules, and we just have to add the rules for it. So just click on this section and go for HTTP, and source can be, so who can access the my web page. So anywhere IP host, so anyone who are trying to access it should have the IP before address, and the type of the security group we are applying is for the HTTP 80 port. Just save the rules, and yes, we are now able to access the uh, web page through EC2 instance. So let's just see if we are able to access it or not. Go back to the dashboard section, instances, and just copy the public IP address and try to paste it here. So as you can see that through the public IP address, we are now able to access the Apache 2 web server default page. Earlier, before, we were not able to access this page because the page was dedicated for the internal private network, which is just for the 172.31.14 and 78. So even if we do the curl localhost, we are able to access the Apache web server page in the private network. But if we want to access this part, access the Apache Web 2 server index page, we just have to go into the instance details, and in the network and security group, we just have to give the access uh, for port 80 to be accessible from anywhere. That's how we are able to now access the Apache 2 web server default page. Yes, sir. Done from my side.
All right. So I hope you understood how to start the EC2 instance on AWS cloud, and then how to get access remotely through SSH connection, and then how to download that key, TM key from the AWS, and then using that key while connecting with the cloud instance remotely using SSH client, and then how to install software, right? To before installation of software, you need to update first sudo apt-get update, and then install the required software. In this case, we install Apache Web Server, and then once you start Apache Server, by default it starts. Okay, you can see the whether status is running or not. In case not running, you can start the service. So you can start, stop, reload. Okay, all these are services available through command lines using system control as well as a service. And then how to test it. So we locally test that web server using curl method, and it was accessible, but then it is not accessible on a public IP address. So I hope with this example you understood how to add a security group so that you can add a HTTP access from a remote, in the sense on port number 80, with the help of a security group, so that you can access the application. Let's say in this case is web server remotely. So thank you, Jay, once again,
Yes, sir.
and I hope. So what our students, what we'll do is we'll finish one more session on AWS S3, okay, by Rohan Pawar, and then we'll provide you some time to practice, and if you have any query with respect to your setup, we will take it. Okay. So should we continue with the Amazon AWS S3 bucket? Vedang, Suyog.
Yes, sir.
Yeah, yeah. So let us proceed with the next session. So Rohan,
Yes, sir. Yes, sir.
yeah, please go ahead with the S3 bucket.
Okay, am I audible and my screen is visible, right? So yeah, to start talking about AWS S3. So how many of you know why the storage service is called S3? So it's a simple. So they thought to keep it simple because it contains three words called simple storage service. So there are three S in the complete, place. That's why it is called S3, simple storage service. So talking about AWS S3. So S3 is a safe place to store your files, right? It is an object-based storage, and the maximum file size you can upload into your S3 bucket is 5 terabytes, and by default you get unlimited storage in your S3 bucket, and files are stored in the object format in the buckets, and yeah, this is the complete definition, and I hope this gives you an idea about S3 bucket, right? So let us talk about the maximums. Okay, so there are 100 buckets per account, 5 terabyte per storage, and 5 GB per port. Meaning, once for uploading the file to the S3 bucket, you need to make a HTTP or REST API request. So in this case, we use put request, and the maximum size which it allows is 5 GB per put, right? Per put HTTP request. So yeah, S3 bucket has universal namespace. I mean, universal meaning it has a public namespace, meaning I will show you. So I was just, yeah. So as you can see in the URL bar, there is a subdomain called important-docs-spit, right? So this is a public namespace, meaning no other namespace is existing with the same name, and followed by the region name, s3 dot region name, then dot Amazon AWS.com, right? And followed by that, there is a directory and the file name, which is called key. Okay, so this is what I mean by universal namespace. Okay, it's like your Instagram username. No other person can have the same, right? And it is unique globally, right? And this is the URL format as I showed to you in the URL bar right now. And when you upload the file to S3, you will receive HTTP 200 of your code, right? And S3 provides developers and IT team with secure, durable, highly scalable object storage. Amazon S3 is easy to use with a simple web service interface to store and retrieve any amount of data from anywhere on the web. And yeah, so S3 is mainly made for things like pics, docs, and JPG files, and uh, uh, like frequently accessed information like profile pictures and the PNG files, etc. So maximum 100 buckets to each account, and yeah. So there is also a constraint that you cannot create one bucket. You cannot create another bucket into already existing bucket. I mean, the nesting is not allowed in the buckets, right? And then you can delete the bucket via AWS CLI. Everything is manageable by AWS CLI. So the tutorial we will be doing is to AWS CLI only. So versioning also is supported by default. It is disabled, but you can enable it in the while creation of bucket, and the files will be versioned so that you can roll back at any point of time. And AWS S3 also supports static website, and you can host your static website in the AWS Amazon S3. And it does not support server-side scripting. I mean, there is no active scripting you can do on the S3. The files will be stored in the passive manner, no activity at the server side. To host a static website, you configure an AWS S3 bucket for website hosting and then upload your website content to the bucket, right? So as you can see in the web browser, as I've requested this file, myfile.txt, the file is not being downloaded to my browser. It has been parsed and rendered into the browser. So that's why it's printing hello world. Okay. So yeah. And the website is then available on the AWS region specific website endpoint of the bucket. So currently I have Mumbai AP South 1, so that's why it is AP South 1 like this. So yeah, it also supports cross-region replication as a bucket level configuration, meaning you can migrate your buckets from one region to another region synchronously without downtime. These buckets can be owned by different AWS account. Yeah, and also there is a feature you can have single bucket accessed by multiple AWS accounts, and it can be managed by AWS console. And there is also a feature for replication of your existing source bucket to direct Amazon S3 to replicate objects for redundancy and disaster recovery. So these are the S3 features in a nutshell. It supports encryption, versioning, lifecycle management, tiered storage available. So tiered storage is something very interesting. Tiered storage is something you have when you want to optimize the existing system. So there are three types of tiered storage available. So that's the one is frequently accessed files. AWS in its infrastructure keep these files in the premium tier so that it can be accessed easily and without much latency. And another one is frozen. So we call it frozen. So in this, the files are stored in such a way that they are not frequently accessed and maybe rarely accessed, so that they are available in the infrastructure but they are not frequently accessed. That's why they are kept in the frozen, right? And there is also a mid-level tier in which you can think it of as a mid-level of both of these. And there is also one more called smart. So AWS actually smartly identifies which files are frequently accessed, and then they keep that in the premium tier, right? So AWS S3 bucket also support ACLs and bucket policy. As I've mentioned in the IAM, we have policy document, and you can also assign the policy document to the particular S3 buckets, right? So these are some stats. 99.99% availability. AWS claims this, and infrequently accessed for data is accessed less frequently but required rapid when needed. Lower fee than S3, but we are charged for a retrieval fees. Right? Everything comes with a price. AWS says that. So so yeah, S3 one zone for data that is accessed less frequently but requires rapid access when needed, but replicated within one zone only. Right? Same thing which I have mentioned. So yeah, and reduced redundancy storage designed to provide 99.9% durability and 99.99% availability of this object over a given year. And the thing I have mentioned, Glacier, very cheap but used for archival only. It takes 3 to 5 hours to restore from Glacier. So yeah, these are some pricing, comparison of the classes, the tiers. So yeah, the same thing. It's like what is Glacier? There is always you want to make sure that you're not burning the money in AWS. So that's why Glacier was introduced when you want to archive your data and we want to keep the data in Glacier so that yeah it so it is the price of this is data for as little as $0.1 per gigabyte per month. So it's way too cheap than other classes mentioned in the previous slide. So yeah, let us not go into more theory and let us create one bucket. Okay, so this is my Alex account. So as he does not have access to the bucket, so I will switch to the root user. Control W. Let's search for buckets. S3 for short. Scalable storage in the cloud. So yeah, as you can see, there is one bucket already created, which I have shown in the browser that it returns simply hello world. So let us create one new bucket. Okay. So yeah, as mentioned in the slide, the namespace is public. So that's why we want to select one unique name for this. Let's say SP. Let's say Voldemort. SPID. Right, and also there is an option so that you can choose existing bucket to get all of the settings and configuration done for this particular bucket. But yeah, I'm going to take you through the settings also. So object ownership. So by default, ACL is disabled. All objects in this bucket are owned by this account. Access to this bucket and its object is specified using only policies. So yeah, we want to create one ACL. We recommend disabling ACL object writer. So let's go with the ACL disabled. And yeah, this section explains lets you enable or disable the public access. So when I showed you in the browser, that bucket was publicly accessible. So I can also keep this bucket private or access through a access and secret key. But yeah, I want to keep it public. So let's say block all public access is disabled now. And by default, keeping it public is not a very good security practice. So that's why AWS make us select one checkbox called I acknowledge that the current setting might result in this bucket, the object within the becoming public. Okay. So yeah, by default, bucket versioning disabled. You can also enable by doing this. So let's keep it disabled. You can add tags for references. And yeah, it supports encryption also, server-side encryption with Amazon S3 Manage. You can also enter your keys and cryptographic information so that the data is being encrypted in the way you want. But yeah, let's say server-side encryption is okay with me. So let's create the bucket. Yeah, successfully created bucket Voldemort SPID. Okay. So let's see if the bucket is accessible. I'll just create one more tab. So by default, it will return nothing because we have not uploaded anything into our bucket. So that's why for the root, it is returning me access denied. So let us explore our bucket now. It's Voldemort SPIT. So yeah, there are no objects currently. So you can also upload the files by the GUI interface, web UI interface, but I would like to do this by CLI. Let's say, are we able to do? Okay. AWS has been installed in my machine, and let us see if I am S3 API. So yeah, I want to apply the policy document to the newly created bucket. So that's why I have a policy already made. I'll just cat that bucket policy.json. As you can see, the SID effect and the principal action S3 get objects, everything is written in this. And yeah, we'll replace this resource with the newly created AWS bucket. So let's modify this policy bucket. So currently we have resource assigned to ARN colon AWS colon S3 and the path of the object. So we need to create this path because we'll be uploading this policy document to the S3 and apply it to the S3. So let us create that via web UI. So I'll create a folder name as mentioned in the policy. I'll name it as ABC. Folder is being created. Okay. Let's upload file. Add file. Let's upload this one, myfile.txt. So yeah, as you can see, the file has been uploaded. And let's say permission, bucket owner enforced to apply for the object ownership. Loaded the file. Okay, let's upload this file. So the file has been uploaded to the bucket successfully. As you can see, upload status and the files and folders available in the current bucket. It's myfile.txt. If you open this up, it will print out the content of the file. Yeah, you can also copy S3 URI. And let's see if we are able to access it via browser. No, it's sorry. It's an S3 URI. Let me share the pre-signed URL. Number of minutes, let's say 300. So yep, if we copy pre-signed URL, we'll be able to see the content of the file. So yeah, this is a sample file for S3 upload test. So we are able to access the file uploaded into the S3 bucket via this URL, Voldemort spit.s3 apsouth1 amazonaws.com. And the object is abc/myfile.txt. And this is all about the the pre-signed URL. It has the same Amazon security token, which lets the request authenticate and then get the file content and render it into the browser. So yeah, and Amazon S3 bucket also support various SDKs like S3, Boto, and you can also access the S3 bucket via access key and secret key programmatically using your web application or mobile application. So this is all of the use cases are. There are many use cases of S3 buckets, and AWS supports all of them. So yeah, that's also.
Yeah, thank you, Rohan, once again for
Yes, sir.
demonstrating
Thank you so much.
AWS S3 bucket. I believe everyone has understood how to create S3 bucket and how to access the S3 bucket, right?
So in this section, we are going to learn about what is AWS VPC, right? So AWS VPC stands for AWS Virtual Private Cloud, where you created your own logically isolated section of AWS Cloud, right? Where you can launch your own AWS resources, where it gives you complete control over the virtual networking environment, starting from selection of your own IP address ranges, creation of subnets, and configuration of router tables and network address, etc. So using Amazon VPC, what you can do, you can launch the AWS resources, you can create the subnet with public or private accessibility, control inbound and outbound access to your resources with security groups, connect your on-premise IT infrastructure via the VPN peering, customize the network configurations such as IP address range and subnets, etc. So let's just see what are the challenges that we face in the traditional networking and why we choose the AWS VPC over it. So the first challenge is that high initial cost. So while creating the traditional data center, we have to put the significant upfront investment in physical network hardware. So it starts from buying routers, switches, firewalls and servers, which requires a big capital expenditure, right? And along with that, we have to buy the license for it, which add to these expenses. Next one is the scalability issue, where as we know that as the network grows, performance bottlenecks can be appear. So to scale beyond a certain limit requires again the redesigning the entire architecture. Next one is the complexity in design and configuration, where we have to choose the right topology for the network traffic that we are facing. So choosing the right topology is very difficult. So for that, we again require the complex network architecture planning and implementation. The next one is the security risk, where preventing the cyber threats like DDoS attacks, malware and unauthorized access is very much important. Right now in today's world, we have to implement the security terms like zero trust security, where it is very complex, but it is also necessary in order to save our traditional data center, right? Then the long deployment time. So setting up physical infrastructure can take weeks or months. So network automation requires complex scripting and orchestration, right? So this is the another drawback of the long deployment time which we face in the traditional data center. So these are some of the drawbacks that we see in the traditional data center, that is high maintenance and monitoring, compatibility and integration, performance optimization, regulatory compliance, right, and geographical challenges. So what is the difference between traditional data center and Amazon VPC, right? So starting from the hardware ownership is that in your traditional data center, whatever the hardware you use, you own it and you manage by itself and you manage by it yourself. The next one is the Amazon VPC, where you have to pay for the resources that you use. So the hardware is always belonging to the AWS people. Second one is the setup time. So in order to set up a data center, it almost takes weeks to months, while in order to set up the virtual private cloud within the Amazon, it takes in minutes. The third one is the cost. So in order to build the traditional data center, it takes huge upfront cost, as we see in the earlier section. In Amazon VPC, it is a pay-as-you-go model. So the resources that you launch in your own VPC network, the resources that you use for X amount of time. For that X amount of time, you have to pay for the resources. The resources, how they calculate, is based on the storage, the CPU and RAM, etc. Right? In terms of security, in the additional data center, we have to have the on-prem firewalls, whereas in Amazon VPC there are built-in cloud firewalls which is easy to use. So this is the differentiation between the traditional data center and Amazon VPC. So our today's learning objective is that by the end of this guide, we will understand how to create and configure our own custom VPC, set up the public and private subnet, configure routing with internet gateway, launch EC2 instance, deploy IDS database, and establish proper security groups. So now we are into AWS console. Just search for the first part that we are going to create is the VPC. So let's just search the VPC and just make sure that you select the region as Asia Pacific Mumbai. So we are going to create our own VPC network within the Mumbai region, right? So make sure that you select the Asia Pacific, which is AP South 1. So let's just search for the VPC, right? The second thing you have to do is click on the VPC and simply just click on create a VPC. Here you have to select the VPC on the section because we are going to create it one by one. So let's just give the name to our VPC, that is SPIT VPC-1. Select create the IPv4 CIDR. So for that we are going to create the B class network. So IP range that I'm selecting for this is 172.16.0.0.0/16, right? Select the section as by default and just create the VPC, right? So we have successfully created our VPC. Now what we required is two subnets. So in this section we are going to create the two subnets. One is the public subnet and another one is the private subnet. In public subnet, what we are going to do is we are going to launch one EC2 instance, where within the EC2 instance there is the Apache web server, and it is serving our web application which is written in PHP via the internet gateway to the WAN network. So let's just create the two subnets, that is public subnet and private subnet. And also in private subnet there will be the IDS, which is the MySQL database, which is connected to the EC2 instance. So let's just create the subnet. So click on subnet section, right, and just simply click on create subnet. Within this, just select the VPC that we have just created, which is SPIT VPC1, right? And in the subnet section we have to create the two subnets, which is public and private. So let's just give the name to our subnet. So first we are going to create the public subnet. So SPIT public subnet. Availability zone will be AP South 1A, and the CIDR subnet block that we are going to give is 172.16.1.0/24. So for first subnet we are going to assign the 256 IP. So within the B class we are going to create the C class network, right? So add another new subnet for this. Here we are going to create the private subnet. So let's just give the name as SPIT private subnet. Select the AZ zone as AP South 1B. So we are going to create these two subnets in two different AZ zones, one which is in AP South 1A and one which is in AP South 1B for the HA availability, which is high availability, right? And for this the subnet CIDR block will be 172.16.2.0/24. So again 256 IPs for private subnet and 256 IP for the public subnet, and just click on create subnet. So this will create our two public and private subnet, that is SPIT public subnet 1, which having the IP address as 172.16.1.0, and another is the private subnet, which is having the IPv4 CIDR as 172.16.2.0. right? So if you want to see the public and private subnet, just click on your VPC, select the VPC ID, and here you can see, just click on the show details so that it will show the IP address ranges. So yeah, so till now what we have done is we have created the VPC, and within the VPC we have created the two subnet which is in two different easy zones. Our public subnet is in EP South 1A and our private subnet it is in EP South 1B. So now what we are going to do is we are going to create the internet gateway. So in order to access our web application which resides in the internet network, we require the internet gateway so that WAN network people can connect to our SPIT public subnet. For that we require the internet gateway. So let's just select the internet gateway section and simply just click on create internet gateway. Here you have to give your name to the internet gateway. So I'm going to give name as SPIT internet gateway and just simply click on create internet gateway. So here you can see we have created the internet gateway. So the next step that we are going to do is we are going to attach it to the VPC that we have just created. So just click on the actions, attach to VPC, and select the VPC region that we have just created, which is SPIT VPC1. Select that VPC region and just attach to the internet gateway. So we have successfully attached the internet gateway to our VPC region. In order to see that we have just created the internet gateway, you just click on your VPC, select your VPC ID, and here you can see we have just created the SPIT internet gateway. Now we require the routing table so that we can create the routing between the public subnet and the internet gateway. So for that, just click on the route tables, select this section as create route table, give the name to our route table. In this case I'm going to give the name as SPIT route table. Select the VPC region where you want to create this route table. In our case it will be the SPIT VPC1. Select this and simply just click on create route table. So yeah, we can see that we have successfully created the route table. So now till now we have created the subnets, we have created the internet gateway and the route table. So now what we have to do is we have to connect our public subnet to the router and the internet gateway to the router, so that whatever the traffic coming from the WAN network, it can go via the route table to the public subnet. So first of all we will create the connection between the public subnet to our router table. For that we have to select the subnet association section, edit the subnet section, select the edit subnet association and select the SPIT public subnet. Just save the association, and we have successfully updated the subnet association for that. The next thing that we have to do is create the route for our internet gateway. So click on add route, select the destination as 0.0.0 so that whatever the traffic coming from the WAN network, it is targeting our own internet gateway. So select the internet gateway and select the internet gateway that we have created, which in our case it is SPIT internet gateway. Select that and just save the changes. So yeah, as you can see we have successfully updated the route for our internet gateway also. So in order to see what we have built till now is that we have created the two subnets, created the SPIT internet gateway and one SPIT route table which is connected to the public subnet and the internet gateway. Okay, so now what we have to do is we have to create our own EC2 instance within the public subnet which we have just created. So select the service as EC2 service, click on the launch instances, and we are going to give the name, which in our case it will be the Apache web server. So write the name as Apache web server, right? Select the Ubuntu image right? And just create the key pair login so that we can able to access the EC2 instance via the public IP to our local remote terminal. So just click on the create new key pair, give the name as Apache -key, and just simply click on create key pair. So we have successfully created the apache key.pem file. Now this is the most important section that you have to look for, is that in network setting, just click on the edit section and select the VPC, which is SPIT VPC1. So by default, the VPC region that it will create the EC2 instance is in the default region. It is in the default VPC. So make sure that you select the VPC region where you want to create your EC2 instance. In our case, it will be the SPIT VPC1, right? And select the SPIT public subnet, right? And enable the auto assign public IP. Now in this security group section, we have to create the two security group policy. One is for SSH so that we can connect the EC2 instances via the local terminal, and second one is the HTTP request so that the WAN network can able to access our application via the HTTP method. So select the HTTP method, select the source type as anywhere, and yeah, so we have successfully added the inbound security group rules. One is for SSH and one is for HTTP, and just simply click on launch instance. So it is creating the instance, and as you can see, we have successfully launched our instances within the public subnet. So click on the instances, select the state as running so that we can see our running Apache Web Server EC2 instance. Select this section and simply click on connect. So as you can see, in order to connect to our EC2 instance, these are many of the options we can connect to our EC2 instance. For now, we are going to connect our EC2 instance via the Cloud Shell. So select the section as EC2 instance connect and click on connect. So it will redirect to the EC2 instance connect section where it will launch the terminal of the EC2 instance which we have created. As you can see, we are successfully able to access our EC2 instance which we have created in the Amazon data center. So click on the clear section, right? So till now what we have done is we have created the VPC, we have launched our EC2 instance within our VPC region. So in this section we are going to clone our PHP application via the GitHub link that we are going to share here. So before that, what we need is the Apache Web Server via which we are going to serve our application to the WAN network people. So write the command as sudo apt update. So it will update the databases, it will fetch the recent dep packages which are required. Okay, so the next command that we are going to run is where we are going to install the Apache Web Server. So write the command as sudo apt get install -y apache 2. So it will simply install the Apache 2 web server. We can see that we have successfully created and launched our Apache Web Server. In order to see if it is able to accessible, we just have to select the public IP address. So just go into the instances section, select the instance ID and just clipboard the public IP address and just paste it here. As you can see, it is showing me by default Apache 2 page. So we have successfully created the
EC2 instance. Within that, we have launched the Apache 2 web server. Now what we required is to launch, or not launch, actually we have to clone our PHP application within the EC2 instance in the Apache Web 2 server, so that the pages that is created in the PHP application can be served via the Apache 2 web server. So let's just go back to the Cloud Shell, right? And we are going to clone our PHP application, which is this link. Just copy it and just write the command git clone and paste the URL. So it will fetch the application for our this demo, and just do the ls command. As you can see, we have successfully cloned the application. Now the next thing that we have to do is we have to move this AWS tutorial directory file to the Apache web server directory. So move the AWS file to /var www.html. Okay, so we have to write sudo and exclamatory mark. So what is the meaning of sudo exclamatory mark is that exclamatory mark means that copy the previous command and attach the sudo command to it. So it will be sudo move AWS tutorials / to the /var / www/html. So it will move the directory to the Apache web server 2 directory. As you can see, it will paste the command which I said before, and just we are going to change the directory where it resides. Enter the ls command. As you can see, it has successfully moved our AWS tutorials to this path that we have mentioned. Now what we have to do is we have to move all the application related files to the current directory. So before that, the index.html file, which is the default page, we have to rename it so that it does not conflict with the index.html file that we have created in the AWS tutorials. So again, write the command move index.html as old index.html. Again sudo exclamatory mark, and we have successfully renamed the index.html file to the old index.html.file. So now what we require is to move all this section to the previous directory, right? So for that, just clear the screen, move the AWS tutorial everything, again mention the sudo command here, to the previous directory. So it has successfully moved our AWS tutorial files, all the files in the current directory. So let's just ls command. So as you can see, it has moved to the www. So we don't have to do it here, just move everything to the /html file. Actually, sudo exclamatory mark ls ls. Okay, so it is within the HTML file, right? So let's just see the front-end application that we have just moved to the /var /www/html section, right? So click on this and just simply refresh this page, and as you can see, we have launched our PHP application successfully here. Now what we need is to connect our application so that whatever the section that we fill here, it can be stored in the database. Till now we have covered pretty much well about the EC2 instance, how to launch it, and we have also installed the Apache web server, and within that we have cloned our application and serving the PHP application, right? So now we have to create a database. As you can see, I have already created the database, but I will walk you through the database setup section. So just click on the create database, right? Here you can see there are many options to select the database. For the demo purpose, just select the MySQL, select the template as free tier, so it will create one database in single AZ region, right? Then in credential settings, set the master password, right? And in VPC region, select the VPC region where you want to create the database. In our case, we will select SPIT VPC1, right? And make sure that the database is not publicly accessible, so select the no, right? Select the AZ preference as AP South 1B, so it will create the database within the AP South 1B where our private subnet resides, right? And just simply click on create database. So it will create our database, so it will take some time. Till then you can just space this command so that it will download the PHP libraries for MySQL connection, and also we require the MySQL client so that it can talk to our database management system, right? And this is the SQL query that we have to paste it once we connect it to our database. So let me show you how to connect to our database within the EC2 instance. So let me just paste the command here. So this is the command MySQL -h. H stands for hostname. So paste this endpoint URL, which is in this section, and here you can clipboard the endpoint URL like this and just paste here, right? -u stands for username, so it is admin, and -p the password that we have set for it, right? Just enter the password, and we are successfully inside the MySQL command. So let's just see the tables that we have created. Before that, we will see the databases. So enter the command show databases. So here I have already created the user management, so we will use that. Use user management, right? So database has been changed, and show tables. So it has created the table name as users, right? So this is how we are able to connect it via the EC2 instance. And just make sure that you assign the security group policy to the database so that our EC2 instance can connect to our RDS system. So for that, click on VPC security groups in database section. Select the security group ID, and in inbound rule, in edit inbound rule, just make sure that you add this save the rules. So that's how I was able to access the MySQL via the EC2 instance.
Yeah. All right, Jay. So you already shared a document, and even this demo is also available to them. In case they have any doubt, they can come and meet personally.
I was audible throughout the session.
Yes.
Whatever I've just said.
Yeah. Yes.
Okay.
All right. Let's move to the next session on AWS DevOps. And I will hand over this, and I invite Pawan Gole. Yeah, over to you, Pawan.
Yeah, thank you, sir. Thank you, everybody, for being here. So, you should really know about DevOps. So, what is really DevOps? DevOps, nothing but you can say writing some code, writing some bash script, writing some tasks that are repeated every time, that are repeated every day. So, we will create a scenario here. So DevOps include CI/CD pipelines. So what is CI/CD pipelines? So CI/CD pipeline basically are continuous integration and continuous delivery. Let me give you an scenario. If I'm a developer and I push my code to the GitHub, let's go to GitHub. So if I push my the code to the GitHub, so before DevOps, what happened if I push my code to the GitHub? A ticket was raised that I push the code, latest code, and then the testing team comes to know that the latest code has been updated. Now we have to perform test. And after the ticket of the testing team has finished, the deployment team came to know that the testing is finished on the latest code base, and now we have to move the latest code base to our server. And when we move our code base to the server, they have thoroughly checked, but it takes a lot of time because everybody is checking, everybody is manually doing the test, everybody is doing something. And if there is little bug, and this process is very tedious, so let's say we can automate the whole process. So what will we do? We have a code in a GitHub. Then we will build the code, like we will perform test on the code. We will perform various tests, like is the code is checking the beauty, like how the code is the code is written well. I perform the unit test on the code automatically. So let's start it. So first what we'll do, we will fetch the code. We will build an executor. In this process, we will create the final deployment file of the code. We will test it thoroughly, and then we will create an artifact of the code, that is final file that going to the server. So in CI/CD, there are various tools like Jenkins and GitLab's Actions, GitHub Actions, also Circle CI, and many more. But in related to AWS, there are three core tools. These are AWS Code Pipeline, AWS Code Build, and AWS Code Deploy. From the name, you're gonna know what this service can do. So AWS Code Build will build the code, like it will run test on the code. It will create the final artifact file. AWS Deploy, Code Deploy will deploy the code to the server. And AWS Code Pipeline will automate this whole process. Like if I push my code to the GitHub, AWS Pipeline comes to know that I have pushed the code to the GitHub, and then it automatically takes the code and push to the server. And in between, it tests all the code. If there are any error in the code, the pipeline stuck there only. It cannot move further. So why DevOps? Because today we want everything to ship faster. Businesses want that our product, our any feature should go to the people very fast because of the competition today we have. So let's start our demo. So we have AWS Code Build service here. I have divided this demo into command line and also GUI that will help you both grasp why this is needed and what are the drawbacks of console and the GUI command line also. So let's take command line first. So I want to push my code, and I want to like Docker as the application, but where I store the image. So AWS provide its own registry, image registry named Amazon Elastic Container Registry. It is same as Docker Hub, but it is not public, it is private to you, and you can only access it. Okay, let me create a registry. So this command specified that I have to create an registry. AWS ACR means AWS Elastic Container Registry. Create repository, and what is my repository name should be, and where the repository region should be. And it has created a registry. Let's see here. Okay, it has created the registry. Now we want to build our code and push the images to the registry. As Rohan has said that in AWS there are list privileges, like there is no access by default, everything is blocked. So we have to first create an role. What is meant by role? Like you have given an ID card. If you have given a student ID card, you can access only the resources given to the student. But if you've given a professor ID card, you can access the resources given to the professor. But you know that ID cards are the same. Like I have created ID card for you. Let's create an ID card. So I have created ID card for the code build. The service is code build amazonaws.com. So now I have created the ID card. I have to assign the privileges to the ID card. That's where the policy comes into play. I have created the ID card. Let's assign the ID card to the service. Okay. Already exists. Let's create another name. So I have created the ID card. Now let's assign the permission to it. So I want AWS code build. What I want AWS code build to do. So everything defines like what you want to do. So I want AWS code build to go to GitHub, pull the code, and create an image and push to the ECR registry. So here ECR comes into play. So I am assigning permission to AWS code build to allow to put image, to upload all the image, like all the Docker push image. So all the permission related to that I am giving to the my ID card. Let's copy it. Okay. Now I created the permissions. Now I have to attach it to the ID card, like to the role. So we given a role, we have to assign a policy. Policy means the privileges we require. Okay, now let's go to IAM. So I have created a role here and I have assigned the policy. The privileges are required for it. So let's go. Okay, now what I have to do? Create a GitHub connection. Like I want to pull the code from the GitHub. So GitHub has to authorize AWS that it should pull the code. Okay. Now we have to go to the console. Settings and here connections. So here it says pending. So we have to update the pending connection. I have already the GitHub apps there. You have to install a new app. Like click here. Then I have to authorize. Enter the password for the GitHub. And I can configure the list privilege also. Like I want to only repository. So connected successfully. So now we have access to the GitHub. We have access to the AWS container registry where we push our images. Now we have to just create. We have all the required accesses to create a code build project. So let's create it. So what will be given in the project? The project name, the source, like from which GitHub we are getting the code, the repo link, and also what role IAM role we are using for that. We also specify the role. Let's say one. So what AWS code build does? Hey, I have a path to go to container registry, and I can push images there. So let's start. Let's say we have code build projects. So the project is built. Now let's start the build. Start now. So the build is divided into phases like submitted, queued, provisioning. Submitted means the build is submitted, but it is not still running. Queued means the build is in the queue now, like it will run in some time. Provisioning matlab it will run, and downloads of like it will running is now, and it is downloading the code from the GitHub. It is installing, rebuild, and build. So you have noticed that it runs the commands. So where are the commands? So the commands are in the GitHub repository only, in the build spec file. So what I have said that log into AWS container registry using this password, and then build the Docker images for this and push the Docker images to the registry. So it is building the Docker images from the Docker files available in the repository here. So what it has done, it has downloaded the whole code. It is running the bash commands to build the Docker files. It is building the Docker file here, as you can see, pulling the images. So it will take some time, and let's now go to code deploy. So I have the Docker images I require in the AWS container registry. So what I have to do now, I have to pull the Docker images from the container registry and push them into the EC2 instance. So which permissions will I require? I will require permission to pull the image from the container registry. But who is pulling the who is pulling actually? So let's talk about it. Let's create an application here. Compute platform is EC2. Like I want to deploy my packages on EC2, deploy my containers on EC2 instance. Create application. Okay. So I want to deploy my package on the EC2 instance. So I have to create an EC2 instance first. Let's set there. Let's launch instance. Let's give the name instance. Free trial. Let's use Ubuntu image. So I have written the commands. So I have written the command to a specific platform, which is not great in scenarios like you have to change images and do other stuff. But Ubuntu is great for the beginners to write commands in bash script. I have, okay. So I have already the key name here. Created SSH as Jay said and launched the instance. So now I have my instance ready. I have code build as a service. I have AWS container registry as a service. So code build will deploy on the EC2 instance. So it will put the script on EC2 instance, and then EC2 instance will go to container registry and it will fetch images from there. So we have to provide permissions, the ID card to EC2 instance also, so that he can go outside also. Let's take a note how actually code build works. So how code build works? So there will be an agent of the code build known as code deploy agent. So the code deploy agent will connect to the code deploy service of the AWS, and the code deploy service of the AWS will provide the script to the AWS code deploy agent on the EC2 instance, and the EC2 instance, and then it will run the script there. Let's do that. First of all, let's provide permission to it. So I already created the code deploy access role. Let's see what this access role contains. Here you can see the trusted entities are EC2, like the ID card is going to the EC2, and EC2 is going outside to other services. So let's say what service it can access. So I have given access to the container registry. I have given access to the code deploy, because the code deploy agent that will be running inside the EC2 instance will talk to the AWS code deploy service. And then I have given Amazon S3 read-only access. We'll talk about this in a minute. So let's assign the role. Okay, now we have assigned the role. Now connect to the instance. Connect. Okay. So we have to install the code deploy agent here on the EC2 instance. Let's install it. In the meantime, let's check for the code build. So it has run this job, and as you can see in the logs that it has successfully pushed the images. Let's say images are there in the container registry. So as you can see, the images are successfully there, pushed by the code build only. So what is it done? It has pulled the code from the GitHub. It has run the Docker commands to build the code from the Docker files to build the images, and push that images to the AWS container registry. So this code build step is done. Now go to code deploy and deployments. Let's check if the agent is running or not here. So the agent service is successfully running on the EC2 instance. Okay, so if the things are perfectly going, let's check the war log files. Let's go to AWS, let's go to code deploy agents, and code deploy agents.log. As you can see, the code deploy agent is successfully running. If any error that gonna occur, it is gonna shown in the log file also here. We will keep an eye on this file. So let's create a deployment group. So I have create an application. For each code base, we can create one application, and for one application, we can create a deployment group, and the deployment group will run the deployments. So let's create deployment group. Enter the service role. So here we are also providing the permission. So what is this service role? Let's check. So code build need the code that it will send to the agent on the EC2. The code will be stored on the AWS S3, and then it will push the code from there and send to the EC2. So that's why we need Amazon S3 permission. And in code deploy load, as you can see, there is allow on the EC2. EC2 describe instance, terminate instance, and get resources. So why this is required? How will code deploy service will know that this instance is the my server? This instance I have to deploy the file. So it does this by taking the into consideration the tags. Let's see how it is done. I assign the code, I assign the permission. I want environment configuration. So it is now it is name and the name of the so how will the code deployment will know that where I have to deploy the code? By using the tags. Here you can see the one unique match instance. If I remove this, there are no match instance. If I added the name, that the EC2 instance having name key as a key. There are two EC2 instance having key name, and if I given a value, there is only one EC2 instance that has matched the criteria given here, key and value pair. So where is the key and value pair? Here, name and what is the name? It instance. So that how will code deploy will know where to push the code, where to push the where to deploy the code. So only once. I don't want load balancer now. Let's create deployment group. So deployment group is created. Now let's create a deployment. So now let's talk about what is stored in the S3. So this is the script that is stored in the S3. This script will be evaluated by the code deploy agent on the EC2 instance. That there will be script folder, and I have to take that script folder and put on this destination, and then I have to run this bash script file. Let's check it out. So this is the file, and the script is this. Like install the AWS CLI, pull the Docker images. If there are already running instances, stop them and pull the latest images, and then run the containers. Now see how it works. So I have to create the zip file of this. I have successfully created the zip file, and I have to copy the zip file in the location where S3 bucket is created. As Rohan Power already told you how to create an S3 bucket, you can create the S3 bucket in the same way and write this command. So it will copy the deployment of zip file in my local instance to the S3, and we have to view the path where the file is stored in the S3. So this is the path. Now let's create deployment. So deployment is created and it is now running. Let's check the log file of the instance. So now we can see here the script file is actually there, and there is container file which was in my local machine. Now it is in the EC2 instance. It is showing failed. Let's check the event why it failed. Okay, let's check the script. Yeah. So there is some mistake in the script. Okay, the location is clear. So then the script part is the mistake. So I think we are good now. Okay, let's see. Let's push again. Let's check now. deployment is succeeded. Let's check. So yeah, the deployment is successfully completed, and now you can see the images are successfully deployed. So let's open the port and see what will be there. Go to security groups. Security. Let's open what is the port number was there. It was 80. Okay, so it is 3000. Edit inbound rule. I will add one rule, custom TCP, and I will put 3000 on from anywhere, save rules. So let's take the IP from here. On the new tab, 213,000. So the application is successfully deployed using code build and deploy. Any question till now? Am I audible?
Yes, sir. That's all.
Okay.
Yeah.
So we have deployed, but we have manually done the thing. Like we go to deployment, we have retried the deployment. We go to code build, and we build the projects by clicking the button on the screen. So this is not how it works. So for that, we will create a code pipeline. So it will automate all those things. Like it will automatically create a build for us, and it will automatically deploy for us. Let's create a code pipeline. So I want to build a custom pipeline. There are various pipelines, like if I only want to deploy, if I only want to build, if I only want to automate. So I have to build a custom pipeline that will involve all the steps. Custom pipeline name should be anything. It will automatically create the service role for you. So here we need not need to worry because it will automatically create it. But on the command line, we have to first create the role and then create the command. So what will our source? So we have already GitHub app, we have GitHub connection, we can use anything. It will automatically fetch the repository name and the branch. So here there is waybook. Like when there is a when someone pushes the code on the repository, someone like pushes or pushes the code, then it will generate an event and it will trigger this pipeline. Let's go to build stage as AWS code build. So there is one thing you have noticed, like what is the input artifacts. Okay, I will talk about it in a minute. So we have already created a build product. We have AWS code build, we have created a project name under it, and we have created a single build, and we are giving it input artifact, source artifact. Source artifact means like I have pushed the code pipeline pushes the code from the GitHub. It's created a zip file and it gives that zip file to code build. Let's skip the stage now and let's create the deploy stage. So here you can see the input artifact is build artifact. First was source artifact. Source means from the code pipeline. It is directly giving the code, but the build pipeline has built some artifacts for you that we are going to deploy. So this is how it goes. We have already created the application name. We have already created the deployment for it. Next, first of all, we have to check if they have all the access, because you can see they are generating some artifacts. So where they are storing the artifacts? They are storing the artifacts in the S3 only. So we have to check the role if we have given S3 full access to them. Otherwise, it will give an error. So let me show where if you create the file. So this will the file will be automatically created in this file. This is the project name. There is build artifact, there is source artifact. In source artifact, there will be zip files. What the zip file contains? Only the code of the GitHub that we pull. And what the build artifact contains? So we have to specify, like we want to create an artifact and what should it contain. So we have specified it in the build spec.ym. Here you can see it is creating an artifact. And what that artifact contains, it contains files. Which file it contains? It contains build output.ht. So if I download the artifact zip file, it will contain this file. Okay, I think we have all the permissions to go. Okay, create file. I think it will do. So it will take some time now. So what is it giving as an auto sort artifact? This is all my GitHub information. It goes on build. There are logs you can see. Here you can see the access denied. We have code with role 1 AWS and S3 get object on this resource is not like why it will show, because it has given an output source artifact. Where is source artifact? In the S3. What is the role it is using? It is using the role code CR role 1. So let's check if this role has the access. So here you can see in the build, under the project name, it has created a build artifact, but the role has not the permission to push to the S3. Let's add the given permission, add permission, attach policies, S3, full access, because it's gonna pull the image, pull the files from the S3 and also push it. So add permissions. And policy successfully attached. Let's retrieve the pipeline. Let's clean it. Okay. So here you can see there is commits that I have updated. So if anything goes wrong, you can roll back on the previous commit, roll back on the previous code. Now it is in progress. Let's see. Does build have the permission now? So as you can see, we have provided a S3 permission to code build, and it can now access the S3, the files that are stored S3 by the code pipeline, and it is running now. So I have now one question for all of you. Will the code deploy will successfully run or not? Anybody? One minute. Like just answer like what do you think? The code deploy will run or not? So in Amazon, you have to only focus on what is the input, from where the input is coming, So you have to give the permission for that. What is the output? Where is the output going? You have to give the permission for the output also. By default, everything is blocked, as Rohan said. You have to allow one thing at a time. So this is called list privilege. So while list privilege, this allows us to finally control like who has the access to the particular resource, and if anybody happens, that person will take the responsibility of that. So code build successfully pushing the images. As the images are already exist, it is not doing anything. So build step has successfully executed. It has given an output. It will give an output in some time. So it has given the output now. So where is the output? The S3. Let's download the file. Let's check what is happening. So it is the output file we have specified there only. And now it is code deploy. It is running in progress. Let's check the execution details here. That is in progress. Let's see the events. So application stop download bundle. It has successfully downloaded the bundle on the EC2 instance. Before install, these are all the steps, and we can specify the steps in the appsyncs.yml file. Here we only specified what will happen after the installation, but before installation we can also specify that. It's running. Okay. Check the I think the agent has some errors in it. Let's check them. So it is saying that status failed, format JSON, script name, the code deployed did not find the appsec file within the unpack version directory as a revision path appsec.yml. Okay. Okay, the failed because code deploy was not able to receive the lifecycle. Check the code deploy logs, make sure the agent is running and can connect to code deploy server. Okay, it's given an error after some time. I don't know the valid reason for that, why it failed, but I think the deployment zip file is good and well. This is code pipeline. Let's start the code deploy agent. It will solve the problem. I think. And we can retrace each stage from here. Like we can start the rolling back. It is successfully done. It is in progress. So it is stuck somewhere. Why? Should run. It is stuck. So that's it. Let me show one more thing. Like the pipeline will automatically start. Okay. So thank you. That's all.
All right, thank you, Pawan. This was fantastic. All right, so with this, we'll end up of today's training session on AWS Cloud. I really appreciate all the students of MTech, as well as I take this opportunity to extend my thanks, gratitude, and to our student volunteers and trainer for today's program. We will take up your questions surely in online mode as well as offline mode. No issues in that.
And so that's why I didn't know how to secure my AWS root account. So what I did, my exams started. Okay, so I just left AWS completely, and out of sudden I just received a mail saying your account has been billed for this month around 90,000 rupees. Okay, so I didn't know what to do. So when I logged into my account, it was something, it was secured with multi-factor authentication, but I realized I didn't know this. Like I didn't do this, right? MFA was not installed by me, and someone else just did that. And because I must be having some less secure password, and my password must be leaked out of leaked some data breaches. So I didn't know that, and I left my AWS account for like 1 to 2 months. Okay, so after 2 months, I received the bill around 90,000 rupees. So that is the the moral of the story was something key. You need to secure your account with multi-factor authentication, and choose your password very cautiously, and which is not being leaked any data breaches. And the best practice is to rotate your password on a weekly or monthly basis. And yeah, the most important thing is make sure you close each and every connection, EC2 instances, and resources. Any resources you must have spun up in the AWS account before logging out or before exiting the AWS console. Okay, so yeah. So later on, I just consulted with AWS support. Some tickets were raised, but uh, I had to leave that account and create the new one, because I could not prove that I'm not the adversary, or I'm not the hacker who just spun up few EC2 instances and started mining on my AWS account. So yeah, that was the story.
Thank you, Rohan. I hope
Also, there is
shall-
section in AWS cost and
Yeah.
budget management if you try to use that service, cost anomaly detection. So it can tell you that how to reduce the cost. And also there is section called billing section in the AWS billing section. If you look into the service, so if you put the threshold according to that, you can able to see. And also the Rohan said that try to close the resources which you have used, so that in order to avoid the bills.
Yeah, thank you, Jay. Thank you. All right, we'll take one more question and then we'll end the session, today's session. All right, any questions? Okay, fine, no issues. We'll take your question in offline mode as well. So once again, I thank you all the participants. Thank you, Jay. Thank you, Rohan. Thank you, Pavan. And especially, I would like to thank the head of department, computer department, Prasenjit Pautankar, for allowing me to take this course online. And through this today's orientation program on AWS Cloud, few of the laboratories we can cover in Enterprise Technology Lab. So thank you once again.